So the question is concurrency always great? So I have come across multiple people who have this faith in their mind that whenever they'll make their code concurrent, it'll perform better. But that's not really true. We can't just take concurrency for granted all the times. Moreover, not all the code can be made concurrent. Because let's say you have a piece of program where every line is dependent upon the action of previous line. In that case, there is no way you can perform things concurrently. You need certain parts of code to be completely independent of one another, then only they can be performed in a concurrent fashion. But wait, what does that mean? That means if I have a program where there are certain parts which can be performed concurrently, is it ensured that concurrency will help us give better outcome? So let's just think about it. So guys, when you have multiple tasks, how those tasks are scheduled on your CPU. When I say scheduled, if you remember, I had said that concurrency is all about time slicing different tasks. So first you perform task A for a few milliseconds, and then you perform task B for a few milliseconds. Then again you go back to task A for a few milliseconds. Then you bring in task C. So this is how you perform tasks. So there is a component in operating system which is called as CPU scheduler, and that scheduler is responsible for doing this ordering of tasks. That decides which task should be given how much duration. And after a certain interval of time, it switches from one task to another task. This is a standard concept of operating system. This is also called as context switch, where you simply switch from the execution of one task to the execution of another task. And this is something which is not fixed. It is non-deterministic basically. So your CPU scheduler might schedule the same set of tasks in a different way when it does it for the next time. So currently if it did like A, B, C, A, B, C, next time it might be A, C, A, B, something like that. Okay. Cool. So I have introduced the notion of CPU scheduler, but let me fall back to the initial question where we were discussing, is concurrency always great? So we realized that if we have a sequential program where next line depends upon the previous, you just can't make it concurrent. But let's say you have an array and you want to compute its sum. So one way is you write a simple for loop, you iterate from 0 to n minus 1 and you find out the sum. So that's a simple sequential fashion. But I can also think of it in this manner. Let me divide this array into some chunks. So let me divide this array into 4 parts. Each part is of size n by 4. And now maybe what I can do is I can compute the sums of these 4 parts in a concurrent manner, because the sum of first part is not at all dependent upon the sum of second part, and so on and on, right? So they can be done concurrently, and then I can say that, hey, if it took T amount of time for the sequential program to find out the sum of entire array, then this time I can expect T by 4. But will that really happen? Let's think of it. So guys, let's go back to our previous examples again. So you have your laptop and there are multiple tasks that are running. So let's say there is a task which was currently consuming CPU, and now it had to wait on network for some event to happen, or it had to wait to read something from hard drive, or it had to wait for the user to provide some input. During that time, when the CPU was idle, some other task could be carried on. Now, what was happening over there was both tasks were happening concurrently. Why? Because the first task did not require CPU, it required something else, network, disk, anything else. And the second task required CPU. So basically both of them were happening concurrently over there. But in this scenario where you are finding the sum of a certain chunk of array, do you believe any of the subtasks will ever need disk or network or user input output? The answer is no. So let's say you have a single processor system, you just have a single CPU core. What will happen? Let's say your first task, which finds the sum of first n by 4 elements, gets scheduled, runs for some time, and then you switch back to the next task, and then again you come back to the previous task, and then again you go back to the third task, then fourth task. This is how you're sequencing. You will find out that it would never ever happen that CPU has remained idle and the task that got switched was still being executed either on behalf of network or disk or something else. So here you can't expect that benefit to be there, because if you sum up the time sliced values of task A, it'll come out to be T by 4 only. Similarly, it will come out to be T by 4 for another task, and then so on for the third and fourth task. And when you sum them up, it will be back to T. So basically, if we try to understand why we didn't get benefit over here was because we had CPU intensive task. CPU intensive task is that which just requires CPU, which does not require other resources. But on the other hand, if you have a task which for some duration requires CPU to perform some mathematical calculations, and then it requires to read something from disk, and then it requires to wait on network, then that task is a non-CPU intensive task. So this is very important for us to understand. If we just have CPU intensive tasks and we have a single CPU core, we can't expect to reap the benefits of concurrency. So it's to be kept in mind. Okay, however, interesting point is that these days hardwares have evolved. Now your CPU is no longer a single core CPU. There are multiple cores, 4, 8, 16, multiple cores have come up, right? So let's say you have your laptop on which you are running this program and there are 4 cores inside it. Then you can expect that the first subtask is being run on core 1, the second on 2, and so on and on. In that case, in just T by 4 amount of time, you would have seen that your program has worked and you would have actually reaped the benefits of concurrency. So guys, I can tell one thing with utmost clarity, that the benefit of concurrency is dependent upon 2 factors. First factor is the nature of task, whether it is CPU intensive or non-CPU intensive. The second factor is the nature of hardware, whether it is a single core or it is multiple core. One more thing, even if your hardware is multiple core, then you have to figure out the number of threads, the optimal number of threads for which your program will run in the best possible time. Because you can't just go on increasing the number of threads just like that. Guys, if you remember the example that I quoted for finding the sum of array on single core CPU, there you had just gone on and created 4 different tasks. There, apart from time t, which was overall runtime of algorithm, some amount of time would also have been consumed in context switches of task, in scheduling the tasks. Because think of it in this manner, when your CPU scheduler has to decide which task to pick next or which task to switch at current moment, that also takes some small amount of time. So if you have so many threads and very few cores, then take this thing for granted that a significant amount of time will end up getting consumed in context switches also, and that can result in a scenario where your concurrent code is behaving worse than your actual sequential code. So we can't take concurrency for granted. There are things that we have to keep in mind to judge its performance.